In the 1950s, Stanley Miller, then a graduate student at the University of Chicago, came up with an idea. We could simulate early Earth conditions in the lab and then carefully watch what happens. If you can't study fish in the sea, set up an aquarium. Working with his professor, Harold Urey, Miller designed an apparatus to simulate the ancient water cycle. Together they put in water to model the ancient ocean. It was gently boiled to mimic evaporation. Along with water vapor, for gases of the atmosphere they chose methane, hydrogen, and ammonia. These are simple gases which scientists at the time thought were probably abundant on the ancient Earth. They added a condenser to cool the atmosphere, allowing water molecules to form drops and fall back into their ocean like rain. The ancient Earth would have had many sources of energy, sunlight, geothermal heat, and even thunderstorms, so they added sparks to the atmosphere to simulate lightning. The goal of the experiment was not to create life, but to simply test the first step in Oparin's model. Can simple chemistry naturally give rise to the complex molecules of life? After running the experiment for just 1 week, their ocean became brownish black. Careful analysis revealed that through a series of reactions, many complex molecules had been produced. Among these were amino acids, special molecules of life that we once thought could only be built inside the bodies of living creatures. This was a pivotal breakthrough in science, so significant in fact that it gave rise to an entirely new field of research now known as prebiotic chemistry. Scientists don't know for sure if the gases used by Miller really were the most common gases of the ancient Earth. Because of this, many experiments have since been done, showing that the molecules of life can form in a wide variety of environments with different starting chemicals and different sources of energy. Sugars, lipids, and amino acids have even been found on meteorites. This suggests that the molecules of life formed all throughout the ancient solar system and may be forming right now in other regions of our galaxy. Together, these discoveries tell us that Oparin's primordial soup and Darwin's warm little pond could have easily existed in one way or another on our ancient planet. So to sum things up, what was the Miller-Urey experiment? The Miller-Urey experiment was our first attempt at simulating ancient Earth conditions, in this case, the ancient Earth's water cycle, for the purpose of testing ideas about the origin of life. The Miller-Urey experiment is significant for two main reasons. First, though it was not a perfect simulation of the early Earth, it clearly demonstrated for the first time that biomolecules can form under ancient Earth-like conditions. Second, the experiment took what was once mere speculation, the idea that life may have emerged from chemistry, and transformed a portion of that speculation into legitimate, testable science. Many questions remain to be answered about the origin of life, but scientists from many nations and many fields of study are now following Stanley Miller's lead. They're finding ways to turn those questions about the origin of life into testable, scientific hypotheses. Simulation experiments cannot tell us exactly how life formed in the past, but if enough of them are done, they could eventually tell us if it's possible for life to emerge from chemistry.